Okay, in this video, I would like to discuss about certain polyatomic ions and how memorizing them would be helpful in order to name compounds and writing the names of molecular compounds from their symbols, or more specifically formulas. So I'll just write a few polyatomic ions. I'm preparing for a quiz. So first is acetate. So that's gonna be CH3COO minus. Or you can say it's C2H3O2 minus. Okay. Next one is gonna be uh, CHO3 minus. This is bicarbonate. In other words, hydrogen carbonate. So why is it like that? So we all know that hydrogen is +1 in terms of ionic charge, and CO3 minus is, well, coming from the second word carbonate. So carbonate is always like this, CO3 2 minus. That's another polyatomic ion. So if you merge them together, so we have H and then 2 CO3. Am I getting it right? Never mind. It's supposed to be, since this is +1, this is -2, we'll just have 1 there, and then CO3. But because this is +1, this is -2, we still have a -1 that remains, hence HCO3. Okay. So that's bicarbonate. What's next? We have nitrite. That's NO3, so NO2 minus. And we also have nitrate. That's gonna be NO3 minus. Always remember those two pairs. What else? I can't remember much. Let me consult my reviewer. Okay. I'll be honest to myself. I'll just read the word. So this is chlorate. We have chlorite as well. This is gonna be ClO3 minus, ClO2 minus. Let me check if I'm correct. ClO3 minus, that's for chlorate. Okay, that's correct. That's nice. Chlorite is ClO2. Okay, that's correct. How about hypochlorite? So that's gonna be, is it gonna be like that? I'm not sure. I'm ready to face the answer. Okay, hypochlorite is just ClO minus. That's gonna be a correction. Okay. So far, I've missed something. But I already know this. It's hydroxide. So that's gonna be abbreviated as OH minus in terms of its formula. So, okay, nitrate, nitrite, we're done. Phosphate, sulfate, and ammonium. That's what you have left. Phosphate, sulfate, and ammonium. Let's go with phosphate first. So PO, I think that's how you write it. Sulfate is, and then sulfite, SO2 minus 4. I'm not sure if what I'm writing is correct. Ammonium is NH3, is it? No. It's supposed to be NH4 plus. This I'll have to memorize. How about sulfate? Okay, I also have a mistake here. It's supposed to be just 2. What about sulfite? Sulfite is 3 below in the subscript. So those are my mistakes. Phosphate is... Okay, I got everything wrong. That's not good. So yeah, I'll have to correct my memorization. Okay. Let me tell you one way to memorize. Where is carbonate? Let me just write carbonate. So that's going to be CO 3 2 minus. So carbonate and sulfite both have a subscript of 3. That's one way to remember. Phosphate and sulfate both have a subscript of 4. Sulfate and carbonate both have a superscript of 2, so negative 2. Actually, also sulfite. The only difference between sulfite and sulfate is the subscript, but the ionic charge is still the same. It's only phosphate that has a 3. By the way, I am also missing something. What is perchlorate? So if this is hypochlorite, what is perchlorate? So this is where this thing comes in. So it's called ClO4. It's what I wrote earlier, except without the minus sign. Okay. Just one more rundown of everything. Okay, something looks wrong. Yeah, I think that's how it is. Phosphate is PO 3 4. What about phosphite? What is the formula for phosphite? but this one's already correct. Phosphite is a different thing. How about bicarbonate, or in other words, hydrogen carbonate? So we have HCO3 minus. After bicarbonate, we have nitrite. Nitrite is NO2 minus. We have nitrate, NO3 minus. We have chlorite, that's ClO2 minus. Chlorate, ClO3 minus. Hypochlorite is just like that, I think. And then per I still might be wrong on hypochlorite. I'm not sure. Chlorate, chloride. I forgot hydroxide. Let's check if hypochlorite is correct. Okay, that's correct. Perchlorate is also correct this time around. How about sulfite? Okay, nice. Sulfate. Nice. Okay. So far so good. Let's start naming now. Okay. Let's start first with iron 2 bromide. So this one, what does the Roman numeral represent in the context of ionic compounds? So that essentially represents the charge of the metal. So again, ionic compounds consist of one metal and one nonmetal. So they bond to each other. And there are policies in how to name ionic compounds. So something regarding the Roman numeral is one of them. So iron, we know that the symbol in the periodic table is Fe. So the charge essentially is, well, the charge of the metal. So 2 plus. It's always going to be positive. And the bromide is the non-metal. So it is abbreviated as Br. And in the periodic table, it's ionic charge because it is in so essentially it is a halogen, and halogens have an ionic charge of -1. Okay? So Fe1, Br2, or in other words, just FeBr2. So that's for number 1. For that. For iron 2 bromide, on the other hand, iron 3, that's basically just going to be Fe3 plus and then Br -1. So Br Fe3. That's it. Okay. Copper 1 iodide. So copper is Cu 1, so that's going to be a +1 charge. Iodide, that's iodine. But what is the charge of iodide? I am not sure. Copper. Okay, so it turns out iodide is 1 minus. So that's just basically going to be CuI. How about copper 2 iodide? So that's going to be +2 charge. Iodide is still -1, so CuI 2. How about cobalt 2 bromide? Bromide is -1. So CuBr2. That's the answer. Cobalt 2 bromide. Sorry, cobalt is, by the way, Co, not Cu. Cu is copper. My bad. Okay, so from the following examples, the next ones will involve, in order to answer them, you need to know polyatomic ions. So this is where the one we did earlier becomes useful. So perchlorate, what's perchlorate again? ClO4 minus, right? How about sodium? Sodium's ionic charge, I believe this is, Na is part of group 1, alkali metals, the one in the very left, together with hydrogen on top. Ionic charge is +1. So if we merge sodium and perchlorate together, so that's going to be the result. Let me confirm if the answer is correct. Yeah, that's correct. Indeed. How about copper 2 nitrate? Copper. And then nitrate, NO3 minus. So CO NO3 Okay, I think that's how you do it. Yeah. How about barium bicarbonate? So Ba, barium. Where do you find barium in the periodic table? So this is in group 2, alkali earth metals. So that's 2 plus ionic charge. Bicarbonate is HCO3 minus. So bring down. Let me just finish this. BA. Sorry, I lost concentration. So I think that's gonna look like that. Is there such thing as barium bicarbonate? Okay, yeah, so that this exists. That's correct. I just verified it. Calcium, hypochlorite. So, okay, is this correct? Let me confirm. Oh, Rick. I made a mistake. Hypochlorite is supposed to be ClO. So, ClO2. Okay. Sodium, the hydrogen phosphate. So, halinaka. This is positive one charge. Dihydrogen, so I think that's going to be 2. And then phosphate. So Na, H2, PO. Okay, so here's what's going to happen. Here is what's going to happen. So since dihydrogen, so we'll have 2 hydrogens, so that makes up plus 3. In phosphate, we have a negative 3, so they neutralize each other. So what we have here is going to be this. So that's it. Okay. So give the names. This one, CCl4 is, let's skip that. CO is carbon monoxide. What's P205? Permanganate? No. CO2 is, you all know that, that's carbon dioxide. This one, Cl2O. This one's water. I think it's also called hydrogen monoxide. Just kidding. It's the hydrogen monoxide. SO3 is sulfur, trioxide. Since oxygen is a nonmetal, we can use the prefix tri. So meth S, or basically mono ditri. How about P4010? What's that? Phosphorus pentoxide. Wow, what? Dinitrogen trioxide. N2O3. Yeah, that's correct. This one is sulfur hexafluoride. P205 is what is P205? Yeah, that is phosphorus pentoxide. But what about P4010? Or maybe they're the same. Maybe. How about CCl4? Carbon carbon tetrachloride. Let's check. Yeah, that is correct. Okay, correct. Wait. Cl2O. Oxygen chloride. Let's check. I forgot. There has to be di because we have to. Okay, that's it for this video. Combustion reactions for the next video. Thanks for watching.